Hello, today we'll talk about physics. Mainly we'll talk about Newton's law. Generally we have three Newton's law, and also there is a law for gravitational. So Newton's law generally it's classified into three laws plus gravitational law. Okay, what about the three laws? It's about first Newton's law, and second, and third Newton's law. First and third, there is no a lot of equation included in this one, but mainly there is for the second law and also Newton's law for gravitation. So first law, he said if object at rest, it will remain at rest. If object in motion, it will continue in motion with the same velocity unless it's affected by an external force. This is for the first one. What about the third? The third Newton's law, he said for every action there is a reaction equal in magnitude and opposite in direction. This is for the third Newton's law. Okay, what about the second law that we will focus on it today? As you see here, we can put a triangle. Here is F, M, and A. F, it stands for the force, and the force is measured with Newton, and we have here mass, and the unit for mass is kilogram, and we have here acceleration, and the acceleration unit is meter per second square. So we can use this triangle to calculate whatever if he asks about the force, mass, or acceleration. How can I use this triangle? For example, here we can put it here again rapidly. Here we said we can put F here, A or M, whatever. We can put M here or here. It's the same thing. So how can I use it if he asks about the acceleration? If he asks about the acceleration, so we can say A equal F over over M, because this line, it means there is a division here, so A equal F over M. What if he asks about the mass? So I can say mass equal to force over acceleration. And if he asks about the force, so I can say F, here there is a multiplication between the acceleration and mass, so I can say that F equal to A times times mass. This is for the triangle. And how can I use it in solving the questions or practice questions? So if you ask about the acceleration, F over M, M equal F over A, or F equal A times times M. Okay, let's go through it. Here he put a general formula that F equal MA. Let's read the first question here. What net force? So he's asking about the force, so he put here F is unknown, is required to accelerate a car at a rate 2 meters per second square. He didn't mention that it's acceleration, but I can look for the unit here. It's meter per second squared, and we said that acceleration is measured with meter per second square, so this one stands for acceleration. So here A, and he mentioned here the mass, so M is equal to 3,000, sorry, he put 3,000. So he's asking about what is the force, so here he put the force is unknown, mass is 3,000, and acceleration is 2. How can I use to calculate the force? So I can say that force is equal to mass times times acceleration. Mass here is 3,000 times the acceleration, which is 2, so I can multiply 3,000 times 2, which is equal to 600, and don't forget to put the unit, which is Newton. Okay, what about the second one here? He said 10 kilogram, this stands for mass. Pulling ball would require what force? So he's asking about the force again to accelerate down alleyway at rate of 3 meters per second square. So this is the acceleration. So here he put the force as unknown, and the mass is 10 kilogram and the acceleration is 3. So again I can put this formula that force is equal to mass times acceleration, which is 10 times 3 is equal to 30 Newton. The third one, Sally has a car that accelerates at meter per second square. So this is the acceleration, so I can put the acceleration here equal to 5. If the car has a mass, so it's the mass which is 10,000 kilogram. How much force? So it's asking about the force, so force is unknown. So again, F equal to M times A. M is 1000 times A, which is 5, so it will give us 5000 watt Newton. Here it's another type of question. Now he's asking about the mass. So what is the mass? So mass here is unknown of a falling rock if it produces a force. So force is what? Force is 147, so I can put here F equal to 147, and the acceleration, he didn't give us the acceleration. Okay, so here it's like a good question. Why? Because now he's dealing with the gravity, because he said in the question it's a falling. So I can put this triangle that here also F, here is M, but now I can use the acceleration due to gravity, which is G, and G has a constant value which is equal to 9.81 also meter per second square. So here's the acceleration. It's called acceleration due to gravity, which is equal to 9.81, and he's asking about the mass. So I can put this formula. He's asking about the mass, so I can say like M is equal to what? F over what? Over G. So I can divide force, which is 147, over 9.81, and I can use the calculator to solve for mass. 1 second, I will use the calculator. Here is it. So 147 divided by 9.81, it's equal to 14.98, and don't forget to put the unit. Now it's what? It's kilogram, because he's asking about the mass. So the fifth one here, what is the mass of truck? So again he's asking about the mass if it produces a force. So this is the force, so force is equal to 14,000 while accelerating, and the acceleration here is 5. So I can again make M equal to force over the acceleration. The force here is 14,000 and the acceleration is 5, so I can divide 14,000 over 5, which is equal to 2,800 kilogram. And that's it. If he just ask about what is the second Newton's law, I can use the also the triangle here to make it easier. Here we said it's A F M, so A equal to F over what? Over M. So Newton's second law, he said like acceleration, there is like a directly relationship between the acceleration and the force. So I can say acceleration is directly proportional to what? To force. What about acceleration and the mass? It's inversely proportional. Inversely means it's opposite. So, and we can complete it, and inversely proportional to mass. So acceleration is directly proportional to the force and inversely proportional to what? To mass. It means that if the force increases, so acceleration also increase. If mass increase, acceleration is decrease. And that's it. I hope it's easy, and thank you.